That means you've changed the signal. It must continue to read H.
Yeah.
So in this case, what must you do? Divide by G. So you don't worry about all the other G's because they are not the ones that you will need to compensate against. So don't focus on everything because it's on the system. Focus on the thing that needs to be compensated against because you change code, with respect to that particular thing. Is that okay?
Yeah. I think I'm getting there.
Yes.
I'm getting there, not exactly.
You must get there. You must get there. So are we together there? Right. We want to simplify our system. So far it looks like this. Now, we have G1, G2, G3. What can you do with those? They are simply from one to the other. This is your process, from this process to that process to that process. What do? Multiply them, which means we can simply in place of those three, we just put one. One process, G1, G2, G3. Are we together? I think we won't manage to finish. What time is it? This is 1 hour for maybe 1 block. Yeah, I will see the way to organize another. Today I don't have that much time. Right. So there we are. Now once we are here, we can simply say this is our G. This is our equivalent G. That complicated system which we have, we can say it's a system with a simple G which is like this. And it also has a feedback H which is like that. Which brings us to another point. When we have a system like this, to do the open loop equivalent of a closed system, okay, what do I want to say? The open loop equivalent of a feedback loop system. So here is a system with a feedback that's our output, that's our input, our summation, the feedback, and the process. Right. For us to come up, we want to come up with the open loop equivalent. In the open loop equivalent, you can clearly see your overall process, your output, and your input, and you can write that in an expression. Okay? So if we want to do it for this one, and that's the other one. Did you keep the original diagram? Make sure you keep it. We are going to do what we are doing now for this simplest one. We are going to do it on that one and see if we get exactly the same result. And we are going to get exactly the same result. Eh? Right. So what are we going to say? If you have a system like this, the reading that you take here, we call that the error. What is the error? We are comparing the output and the input through our feedback. Then the reading here, that's your error. And the purpose of doing this is obviously to what? To control. If these are not the same, if the error is big, that means our system is running uncontrolled. Okay? So we must have some parameter which we say, okay, this, for example, if it's temperature, let's say a simple thing is an ironing process. Ne? You have inside there that thing, what do you call it? Thermostat. If the iron is becoming too hot, so you are comparing the input, the output, and then when you compare there, too hot, what does it do? It trips. The process is what? The ironing at a certain temperature. So you want to iron at a certain temperature. And so you are taking a reading from there, feeding back, comparing to what you want, and then you make a decision and do something. So that's the purpose of control. Ne? If it becomes too hot, then you can't put your shirt again. You can't put it on again. Eh? If you use those other ions, the temperature continues to just increase. So if you do that, what happens? You lose your shirt. So you don't want to lose your shirt. What do? You now put a control mechanism which compares what is coming out. In that case, what is coming out is read as the temperature. The moment the temperature gets to a certain amount for that, whatever you're ironing, then it must trip and bring it back. So that's the feedback. Feedback is reading that output and then making a comparison with a certain standard and then making a decision. So the error here is what we check. If, let's say, we want to iron it at, I don't know the temperatures for ironing, forgive me, but I'll just say a value. Suppose we iron it 60 degrees. I don't know the actual. Don't say it's wrong. People correct things which are not to the point. That's not the point. Please, I don't know at what temperature we iron. Suppose it's supposed to be at 60 for whatever you're ironing, and it gets to 70. You are in trouble, ne? So what is the error? The error now is the comparison of the reading and the actual output which is coming out, which you then use to then go on and do your control. Are we together? So, that's the error there. So, we can solve this analytically, and we are going to go on and solve that whole big system using the same method. We did by block reduction, and so far we are here, and we are just about to finish when we understand this. So, what is your error? Can I... Okay, let me use this side. Let me use this side. Right. So, error is equal to RS minus YSHS. In this case, we are saying the signal here. We can see RS is coming positive, and we are subtracting the signal coming from the other side. What is coming from the other side? We are picking YS here. Okay? This whole thing is YS. So we are picking YS, and we are checking it, passing it through H. So what is the signal? YSH. Okay, let me remove the HS. I didn't put the S there. Are we together? Are we together?
Yeah.
We have picked YS, we passed it through H, and we are subtracting the whole thing.